Okay, so what we have here is a resistor, or not a resistor, but a circuit with several resistors in it that are connected in a fairly complex looking fashion. Over here we have a 12-volt battery. This is a 110 ohm resistor. Well, I guess you can read those, that's fine. And the objective is to find the total current in the system and the voltage across point A and B. So what I've drawn here is maybe another rendition of this circuit here, where we have the 110 ohm resistor here, and that's connected in series to another set of parallel resistors who are also in their own configuration. Oops. So what I'm going to be doing is trying to reduce this down into one equivalent resistor. So I can first combine these two, and I can get a resistor that's, oops, that's my battery. So there's the 110, and I can get a 470 ohm resistor here. And I still have the 180 here and the 110 here. So now I'll need to connect these using the parallel resistor formula, which is R total equals 1 over R1 plus 1 over R2. So that's equal to 1 over 470 plus 1 over 180. So what did y'all get? What did y'all get for this this result? Did you not get this one? Okay, so for this I get 130.2 abouts. So once I've connected them in parallel, then I can have my 110 and then that resultant resistor connected in series. So I have 110 and 130.2, and now I can connect those into a single resistor that would have an equivalent resistance of 240.2. Okay, so now we've got our voltage for the battery was 24. We've got the equivalent resistance. So now we can find the current. Remember that V equals IR. So the voltage is 24. We don't know what the current is, and then the resistance is 240.2. So we divide that over, and we get about 0.1 amps. Okay, so now we want to find the voltage across point A and B. Now something that you might, if we're looking at this original drawing, you might think that it's just over this resistor, which makes sense because it's the straightest line. But you have to remember that electricity isn't going to work that way. It's going to go through everything that's connected to it. So the voltage from A to B is going to go across this wire and this wire. So what we want to do, instead of using V equals IR just over this resistor. What we want to do is use the equivalent resistor that we found for this parallel system here, that we found right here. So really, here's point A, and over here is point B. Oops, that's an R. And over there is point B. So the current across here is going to be 0.1. The resistance is 130.2. So then the voltage would equal the multiplication of those two. So we should get that the voltage equals about 13 volts.